Alright, so we've learned some of the graphs, the cubic graphs, the quartic graphs, like before, but now we need to learn some transformations. So in total, there are 6 transformations that we need to be aware of, and I've written them down for you on the screen here. So let's go through each one. So the first one is when we have y is f of x plus a. So in this case, we translate it. Translate just means move left or right or up or down. So we translate it by positive a in the y direction, meaning the whole graph will move up by a. If a was negative, then it will just move down by a. If we have y is f of x plus a, so plus a is inside the bracket now, then we're going to translate it by minus a in the x direction. So if it's like x plus 2, then you move it left by 2. So it's like the opposite of the a sign. If we have the a's outside, then it's a stretch. So there's 2 stretches we need to be aware of. So we have y is a f of x. So if a is 2, then we stretch the y values by 2. If it's a is inside, we stretch by scale factor 1 over a. So in fact, if it's inside the bracket, then rather than stretching it, we actually shrink it or divide all by a. And then finally, we have y is minus f of x. Then we reflect it in the x-axis, so we flip it up and down. And y is f of minus x, then we flip it left and right. So we reflect in the y-axis. So as I said, you need to be aware of all 6 of these transformations. And you need to remember what happens when we apply these transformations to each graph. The way I go about remembering it is I look at where the a is. So what I mean by that is, well, if I see the a outside the bracket like here, or like this one here, right? Then I think to myself, oh, it's going to affect the y values. So it's going to affect, in this case, the first case, it's going to plus a, so it's going to affect the y values by adding a. If it's outside like this, it's multiplied right, so it's going to multiply the y values by a. Okay, that's how I remember it. If the a is inside the bracket, like in this case and this case here, then I think to myself, oh, it's going to affect the x values, but it's going to affect it in the opposite direction to a. So if it's, as I said, if it's x plus 2, you'd expect it to move right by 2, right? But the opposite direction means moving left in the x direction by 2. Once again, if it's f of 2x like this, then you'd expect it to multiply by 2, right? But it's the opposite one, which would mean you divide it by 2, so you shrink it by 2. And then finally, if this, for the reflection, the minus sign is outside the bracket, right? So you think to yourself, oh, it's going to affect the y values. So how do y values get affected? Well, get affected when you flip them up and down. And if it's inside, then how the x values get affected? Well, you flip it if you flip it left and right. So that's my way of memorizing or remembering how to do each transformation. Maybe you guys can just practice yourself or just think of a way yourselves that you can just memorize it more easily. Okay. So let's try a question here. So we have a curve with equation y is f of x, and it passes through the points a, b, c, d. So these are the original points, and now we're going to apply some transformations to these points. So you can see here a couple of transformations, and they're asking you the coordinates of a, b, c, d after each transformation. So I'm going to write out the first coordinates first. So a is minus 4, minus 6. B is minus 2, 0. C is 0, minus 3. And D is 4, 0. So all these transformations are going to be based upon these original coordinates. So let's start off with each one. So first things first, we have f of x minus 2. So the value, our a is minus 2 in this case, and it's inside the bracket, meaning it's going to affect our x values and do the opposite side. It's going to do the opposite. So rather than minusing 2, it's going to move everything to the right by 2. So it's going to affect the x values by adding 2 to each one. So in this case, a will be minus 2, minus 6. B will be 0, 0. C will be 2, minus 3. And D will be 6, 0. So as you can see, the whole graph has moved to the right in the positive x direction by 2. Part B, f of x plus 6. This 6 is outside the bracket, so I know I was going to affect my y values and affect it as I would expect it. So plus 6 means move up by 6. So all the y values will move up by 6. The x values will remain as minus 4, and then this will be 0, minus 2, 6, 0, 3, and 4, 6 like this. So the x values don't change, it's just the y values. C, we have f of 2x. Once again, it's inside the bracket, meaning it's going to affect my x values and do the opposite of what I expect. So rather than timesing by 2, it's actually going to divide by 2. So divide each x value by 2, leaving the y values as they would be. Minus 1, 0, 0, minus 3, and 2, 0 at this. Let's try, well, this d is the same thing as a, so we'll skip that. Maybe we can try this f here. So it's 3 f of x. As you can see, the 3 is outside the bracket, meaning it's going to affect my y values, and then multiply them by 3. So it will be minus 4, minus 18, minus 2, 0, 0, minus 9, and then 4, 0, like this. Maybe you can try this one here. f of a quarter x is inside the bracket. Affect the x values, do the opposite. So rather than times a quarter, you divide by a quarter, which is the same thing as multiplied by a quarter. So it's going to expand by a scale factor of 4. So minus 16 comma minus 6, minus 8 comma 0, 0 comma minus 3, and 16 comma 0 this. And let's try I, so f of minus x, so minus f of x. The minus is outside the bracket, right? So therefore it's going to affect my y values, and that's going to be reflected in the x-axis. The y is going to change values. So we're going to have minus 4 comma 6, minus 2 comma 0, 0 comma 3, and 4 comma 0. And f of minus x will therefore affect the x values, so the x value signs will change. Okay, so that'll be 4 comma minus 6, 2 comma 0, 0 comma minus 3, and then minus 4 comma 0, like this. So as you can see, as long as you clearly remember what each one does, then it's not too difficult, because you can just imagine what's going to happen to each individual point. So maybe take some time to practice some of these transformations yourself and just try and find a way for you guys just to remember it a bit more easily.